Okay, so we're going to continue with the composite images, talk about raster data. So the first part, we have to know that satellite-based cameras and instruments can provide high-resolution imagery. However, because each image is typically captured at a particular wavelength, and when we combine images of the same thing at a number of wavelengths, and then the whole becomes much greater than the sum of its part. So here we will produce composite images in both true and false color and explore how combining different wavelengths allowed us to differentiate features in a particular scene. And we will produce and explore this composite imagery to observe how a landscape changes. We will observe urban growth and agriculture decline. So that's interesting to see the land use. So because in remote sensing, we use those images to detect the land change. So remote sensed and acquire imagery from satellites such as Landsat. So we're going to talk about Landsat in detail. So then the different bands and what information we have here. So that such as Landsat are typically grayscale and acquired using a particular diffraction grating or filter. However, imagery of the same area taken with different filters can be combined to generate a true color scene or false color scene. So a color scene image is generated by mixing three grayscale images or bands representing blue, green, and red, respectively. Since color images are composed of combination of red, green, blue light, and generating color images from remotely sensed data requires to use a combination of at least three bands or represent true color. So now the image needing three channels or three guns. So the blue, green, and red to create a color image. So the true color image we will have to see here. So Landsat measure things. So true color. Okay. So here it mentioned that each range is called band. So this one for Landsat 8 we have 11 bands, and Landsat number red, green, blue, and sensor 432. So we combine them, get a true color image such as this one. So it's very difficult for me to remember which band is what color. So I don't know for you guys, but here are 11 bands. So the bands we can go over a little bit. So each of the grayscale images actually corresponds to these colors. A natural or true color image can be produced, and we can also combine different bands to produce images that highlight or display land and color feature differently. And these bands may be visible wavelengths such as red, green, blue, or they may represent wavelengths we cannot detect with our eyes, and the table represents a short summary of the characteristics of the most common band combinations for Landsat TM thematic mapper imagery. Recall that different band combinations will have a different interpretation. So for the wavelength, so the first one, 0.5, this to 5 something, this is blue band. Number 2 is blue band, and then this should be green band, 0.25 to 6. Yep. 0.3, this will be red, blue, green, red, and then we will have a near infrared, and then we will have a short wave, 1.5. 7.6 something, but it's close here. And here 8, we will have a 10 point something. This is thermal. So I guess they have a near infrared, shortwave infrared. They separated 2 to something, and shortwave infrared is right here. And then thermal, and then this one band 11. 11 bands shortest wavelength serve. So bands 1 to 4 and 8 sense visible light. So all other parts of the spectrum that we cannot see. The true color view from Landsat is less than half of what it sees to understand the value of the bands. So we will look at one by one. So this is band 1. the previous didn't have. So the sense deep blues and violets, so blue light is hard to collect in this case, so because scattered easily by tiny bits of dust and water in the air and even by air modules themselves. So this one reason why very distinct things like mountains on the horizon appear bluish and why the sky is blue. So we can see a lot of haze blue when we look up the space on a sunny day. So Landsat A sees the sky below it and it looks down at us through the same air. So the part of the spectrum is hard to collect with enough sensitivity to be useful, and band 1 is the only instrument of its kind producing open data at this resolution, one of many things that make this satellite special. So it's also called the coastal aerosol band. Oh, cool, coastal aerosol band. So this is band 1 for Landsat A. That's interesting. So this website is from NASA, okay, about Landsat A. So the NASA, we have a Landsat 8. So the first one, band 1, it is the coastal aerosol band. Okay, and it also, after its two main uses, imagery shallow water and tracking the fine particles like dust and smoke by itself, outputs band. So it looks like normal blue, but we contrast them and highlight areas more deep blue and can see the differences. Cool. So here, band 1 minus band 2, the ocean and living plants affect more deep blue violet hues. So more plants produce surface wax. So for example, the forestry coating on the fresh palms, so they grow, they reflect harmful ultraviolet light away. This is band 1. Cool. Okay, alright, so the sensors detect this, and the bands 2, 3, 4 are visible in green, red, but while we are revisiting them, let's take a reference section, so Los Angeles with a range different land use compare against the other bands. So let's compare. Part of the western Los Angeles areas, so we will see agriculture land near Honored in the west of Hollywood and downtown in the east, like most urban areas. So the color of the city average out to light gray at this scale. This is band 5, so it measures the near infrared or NIR. So this part of the spectrum is especially important for ecology because healthy plants reflect it, and the water in their leaves scatters the wavelength back into the sky. By comparing it with the other bands, we get intersect light NDVI. So that's how we did a lot more research using the area imagery. So the bright feature are parks and other heavily integrated vegetation. So the point near the bottom of its view on the west of the Malibu, so it is a safe belt that the color bright spot in the hills is near golf course. That's interesting. On the west edge is the dark scar of a large fire, which was only a slight discoloration of the true color image. So that's very interesting. And we could look, if we could download the image and look, and that will be interesting to look at the last year, the white file in the Southern California. And band 6 and 7 cover different slides of the shortwave infrared of the South SWRI. They are particularly useful for telling wet earth from dry earth and for geology, rocks and soils that look similar in other bands often have a strong contrast as in SWIR. Let's make a false color image by using this as red, infrared as green, and deep blue as blue, technically 751 image, so that this fire scar, now it's impossible to miss. So reflecting strong in band 7 and hardly or in others, making it red, so which is right here, a previously subtle detail, so this cannot tell yeah, we cannot really tell if maybe we just thought, oh, the vegetation grows well there, so if it didn't mention there. That's interesting. So previously, the subtle detail of vegetation also become clear. It seems that plants in the canyons north of Malibu are more lush than those on the ridges, which is typically climates where water is the main constraint on growth. We also see vegetation patterns with LA, Los Angeles. Some neighborhoods have a more foliage, parks, sidewalks, trees, lawns than others. So the band A is the panchromatic. Just pan band. It works like a black and white film. Instead of collecting visible color separately, it combines them into one channel. So because this section can see more light at once, this is the sharpest of all the bands with a resolution of 15 meters, around 50 feet. Let's zoom into Malibu in 1:1 scale in the pan band. So that's here. We have the color version. The sensor cannot see detail here, so this is really detailed. So this one we cannot see. Then we combine and put the color and everything. That's really nice. Band 9. One of the most interesting feature here in Landsat. It covers a very slice wavelength, only this nanometer, and few space-based instrument collects its part of the spectrum. Because the atmosphere absorbs almost all of it, and Landsat terms this into an advantage precisely because the ground is barely visible here. Anything that appears clearly in it must be reflecting very brightly and or be above most of the atmosphere. So here is the band 9. So band 9 is just for clouds. So here, picking up fluffy cumulus clouds, but it is designed especially for cirrus clouds, high wind speed, horse tails, and the cirrus are a real headache for satellite imaging because their soft edge make them hard to spot, and an image taken through them can contain measurements that are off by a few % without any obvious explanation. Band 9 makes them easy to account for, and bands 10 and 11 are the thermal infrared, or they see heat instead of measuring the temperature of the air like weather stations. They report the ground itself, such as much hotter. So here, thermal infrared sensor. TIRS. They use the algorithm correct for this issue, developed and implemented for the processing system since February 2017. And we can see the study, a study a few years ago finds some desert surface temperature higher than 70 degrees, hot enough to fry an egg. Wow. And luckily LA is relatively temperature in the same. So, and putting color, I like to be in colorway. So irrigated vegetation is coolest, allowed by open water and natural vegetation, and burn scar near Malibu, which is covered in charcoal and the dry. Wow, cool. Dead foliage is a very high surface temperature within the city. Parks are generally coolest, and industry neighborhoods are warmest. So there is no clear urban heat island in the scene, and effect that these thermal infrared bands we can particularly useful study. So even for Los Angeles, they didn't say urban heat island. No clear urban heat island. Wow, that's really cool. That's a good question. Okay, bands can be combined in many different ways to reveal different features in the landscape, and we will make another false color image by using the thermal infrared band for red, band for green, and natural green band for blue. So that's the image look like. So the urban area and some kinds of soil are pink, so which is right here. In the true false color image, white vegetation almost uniformly olive colored. So these are the vegetation, but we can see a distinction between peach color and a scrubbed land, like these. So peach color and scrubbed land. and then the color strips on either images where do not have sensor have a coverage. So the strip is right here. So that's really interesting to know. But here it published. There's, I think sometimes. Maybe it was an article. Okay, published on June, original posted, but I think they updated. So because they add this, so April. So, all right. Now for the book that we have is page 143. So now I'm gonna start my ArcGIS Pro. So 3, 2, 1. So this band combination creates a true color or natural image, and this band combination is useful for bathymetric and coastal studies. So and we already went through there. So but we can just went over here real quick. But it is interesting that even for Landsat, band 8 is the yeah, we do look at coastal and aerosol band. So for band 432, using band 4 in the red channel results more sharply defined water boundaries than the 321 combination. By displaying this band that senses peak corollary reflectance as red, vegetation appears red. Generally, deep red hues indicate broadleaf and healthier vegetation, while lighter reds signify grasslands or sparsely vegetated areas. Densely populated urban areas appear as a light blue. So 742, this combination retains the benefits of using the infrared bands, yet represent vegetation in familiar green tones, and shortwave infrared band 7 helps discriminate moisture content in both vegetation and soils. And urban areas appear in varying shades of magenta, and grasslands appear as light green. So with a band 453, with this band combination, vegetation type and condition display as variations in hue, browns, green, and oranges. So this band combination highlights moisture differences, and it's useful for analysis for soil vegetation conditions. So a lot of graduate students study remote sensing and calculate those vegetation and change, and wetter soil appears in darker shades. And now we're going to do is creating multi-spectral imagery of the Chesapeake Bay. So now Chesapeake Bay Foundation managers are seeking for an analysis of multi-band spectral imagery of the Chesapeake Bay of a specific area of interest, and they want to use composite imageries to monitor urban growth, study the extent and patterns of turbidity. So observe beach erosion and look at shoreline change and map water pollution. And our job here is to generate color composite imageries and identify areas of interest. So we will have to write one paragraph about that. So for the deliverable, we will going to do is we will generate a base map for the Chesapeake Bay and isolated study area, and a written assessment of the information offered by the different band combinations, and a written report that including images with the different band combinations. So the questions that follow are both quantitative and qualitative. They identify key points that should be addressed in the analysis and presentation. So here are the tips and tools that we will have to get things ready. And so now I'm gonna do is go to a blank, and I'm gonna save in my folder. So go to my desktop, ArcGIS Pro, and then we will save it into this making spatial decision. And this one we have is the checker. Okay, Chesapeake Bay. Click OK. So now, once I have it, and then I will have to extract the go to insert and add a new map. Okay, so when I add a map, so the band, we will have the ribbon. So we have a map, and we have a help button, and you can, if you need help, and we can just go over. But here we will explore raster dataset. And when a raster display here, we will select the appearance and set the remember, we have a stretch, and we talk about how to present the raster data already. Okay, and we can explore the raster tools in the geoprocessing pane by searching for all tools related to the search term raster. Okay, so now I'm gonna go to raster. Okay, so raster, we will have a lot of tools. Oh, not catalog. So I'm gonna go to analysis and toolbox. Okay, I'm gonna type raster. So we will have a lot of tools that related that we already explore in our work. So now we're going to extract the map package. Hopefully it work. Okay, so I would say extract package. So not extract by points, extract package, and I'm gonna go to my downloads. Remember, I get all the data. So check a peek, okay, and then output folder. So I'm gonna put into desktop and folder, making spatial decision, and click run. So once we have the data and we can run, I'm gonna go back. Oh, just have to take a little time. So for ArcGIS Pro, we could do is wait a little bit, and then, alright, it's done. So now I'm going to catalog. So my catalog, okay, favorites portal, okay, right here. So project, go back. Okay, so now we're gonna connect to our folder. So, okay, oopsies, alright. Okay, so then I'm gonna expand the folder and see, that's my folder. I don't think it extracted. So here it didn't extract it for me, so I have to do the same way. So now I'm gonna go to not my Google Drive, so it will be downloads. So downloads, check peek results, and then I'm gonna extract it here. Extract it here. Oh no. I'm gonna cancel it. Yes. It just create a lot of I'm gonna remove, okay. Delete, okay. Alright, so Win7 extracted files. Okay, then I'm just click download. Alright. Once we have the folder, I will just cut it and put it into my folder. So I click on it, and then I'll just say cut and go to desktop and go to my folder and paste it there. Paste. Alright, so then I will do is I'm gonna refresh. Right click and refresh. And I have the folder. Okay, now P12, P13. So that's interesting. So, but we have to go as to, the 13 one. So in the catalog pane, we have right click on the folder and add folder connection, which I did, and we add the data folder where we extracted the package. So the folder connection will remain in this project for the whole time while we are working on this data, and the folder connections are specific to the project in which they are created. So inside the data, folder, we will see a P folder that contains the new Bay geodatabase, which is right here. So new. Okay, and then we will expand it to see what kind of layer is right here. Okay. Expand. Alright, so everything is here. And then inside the data folder, we will see P folder that contains this, so P13. That I expanded, we will right click layer and add to current map. And we will right click on multiple, where did it go? Okay, yeah, multi-spectrum 2006, and right click on it and add to current map. So alright, so then when we add the data to the map, ArcGIS Pro creates layer for each data source, and the layers reference the actual source data and can contain many different display properties. For example, we can change the colors of layers and how they symbolized, and the layer name and the label. So now I'm going to rank everything. So we have a state and area of interest. So study area. I'm gonna rename things. Okay, this will be highways. Okay, highways, and then this will be Control A. So it will be areas of interest. Okay. So, oh, this will be area of interest. Okay. Area of interest. Oh my god. Okay, this one. Selected. No, not this one. Okay. This one was the study area. Study area, but I need a selected sheds. Selected shed rivers, and selected shed rivers, and then we have rivers. Okay, we have a rivers. After rivers, oh no, selected shed rivers. Rivers, selected sheds. Okay, selected shed rivers, selected sheds. Selected share river. This is river again. The name is really weird. Okay, selected sheds. Okay, oh, selected sheds, selected shed rivers. Okay, I have to rechange this. Okay, selected sheds. Okay, selected sheds and selected shed rivers. This might be selected sheds rivers. Okay. So I have area of interest, selected shed rivers, and then rivers, and then I have a selected sheds, multiple 2000s, multispectral 2006, selected sheds. Okay, I'm gonna rename it. Okay. Multiple RGB, and then we have a study area, and we have a bay shed and states. Bay watershed. Okay, bay watershed. Okay, then we have a states. Okay. So we have a highways, and we have an area of interest, and we have a shaded, selected shed rivers, and we have a rivers, and we have a selected shed, and we have a multispectral 2006, and we have a study area, and we have a bay watershed, and we have a states. Okay, now I'm gonna save it. Okay, now we can see the data. We can see the data a little better now. It displays in this order in the contents pane here. And now it's a good time to familiarize with ourselves with the GIS operations such as zoom, pan, and everything. We will explore a little bit. We should also take a minute to explore both of the data and the interface. And we will see if there is a content pane, a map view, and a catalog pane. We can run the layer on and off and the contents pane and become familiar with the different layers. We also identify point, line, and polygon features. So in the quick access toolbar, we will save the project. I already did. And the map derives its coordinate system from the first layer added to the map. So now in the contents map, we will right click on map, which is right here. So I'm gonna right click on it and go to property. And in the map property, I will have a map window. We have the coordinate. So I click this and then actually I don't know. Let's just look at highway for the coordinates. I'm going to go to source so I know what kind of spatial reference. NAD zoom 1983 UTM zone 18 north. So in the next section, we will set the output coordinates for geoprocessing to the same coordinate system as the data frame or the first layer, because this projected coordinate system most accurately preserves measurements within the localized area. So now here in the catalog pane, I will select project tab. Okay, click OK, project tab, which is right here, and then I will expand database. So now up here, database, and I'm gonna expand here and identify the shipping results geodatabase, and this database will store all of the produced data file and the database everything here in the new Beijing database, which is the data source. So that now we're going to set the environments. So I'm going to dock this ribbon. So I have a big screen, so I whenever I want it, then I can just open it and use it. So the first one that I'm gonna use is set the environment. So the geoprocessing environment settings. So we will make sure that the geoprocessing is performed in a controlled environment. So here in this section, we will establish environment settings for the project. And we will set this environments, ensure that our data will be stored in appropriate place with the designated coordinate system. So now here in the analysis tab, so I'm going to click the environment, which is right here. So for the environment, okay, and we will set the following parameters. So here, Chick Bay are already here. So now the coordinate system. So the coordinate system the same as highway. So now we know it's MAD 1983 UT and zone 18 north, and we will click OK. Everything looks good, then I click OK. And we will create a process summary that we can continue, so that we are all working with this raster data set. So it will be fast, okay? So it's interesting that we will not have a lot of map or vector like points, lines, and polygon. We are not dealing with those now. We are dealing with images, okay? Images, okay? And then for next module, we will deal with the classification, so that we will use the image to generate different images, and we will classify it, and we will have some stuff there. So it's very interesting to do it. And then we will learn a little bit about supervised and unsupervised things, and we will go to LiDAR data. So there was another book, it's just dealing with the LiDAR data. That's very interesting. But I don't see a lot of job application that really care for really care for the light data, but they do need other stuff, okay, and location of the solar pans. That what we're gonna do, and then we will do the forest vegetation height. I think that will be 3D models, okay. Okay. Okay, we did was that process summary. We will list the steps we used to do with our analysis, and the summary allows us to or others to produce our work. So we suggest using a simple text document for our process summary, and we can add to the summary as we do our work to avoid forgetting any steps. So now it's just like a to-do list, and I did this, I check, okay. First we extract the project package, and we produce map of the Cheek Bay watershed, and we're gonna create different bands combinations. That's what we're gonna do, and interpret the false color composite imagery. So we're going to do a false color image. So the analysis, once we have obtained the data and set the environment, we are ready to obtain the analysis to compute the data display, and we must adjust the problem. And for this module, we have been asked to create different color composite images already. Now we're going to do is here on the contents pane for state, I'm going to go to unique values. So go to symbology and go to unique values. For unique values that I have to change is the value field. We are going to do, it will be state abbreviation. Right here, state abbreviation, and we will click more here. So I'm gonna do not show these. So we have DC, Delaware, Maryland, New Jersey, Pennsylvania, Virginia, and West Virginia. Okay, so now we're going to see states and label. So now I'm gonna go to states label. Okay. Okay, so label, and for the label that we can label classes to restrict labels to certain features. So here we will only use class 1. We will change the class 1, only use class 1, and change field to state abbreviation, and then choose basic polygon, and then several label positions are available for polygons by default. So boundary, polygon, land, parcel. So here is basic. Polygon labels are placed horizontally within polygons. So let's see. Okay, nope. Where did it go? How can I see all? There, right here. So we can see that we can also place label along the media axis, or following the general curvature of the polygon. We can repeat any of these interior label throughout the feature. So if polygons are too small to contain the labels, we can place the labels horizontally or curved outside the polygons. Whether the polygon is labeled within the polygon or outside the polygon, we can control the zones that will be used for placing the labels. Well, now we will change the text symbology to bold. Okay, so I'm gonna choose bold. Okay, so now we will turn on the Chesapeake Bay. And double click polygon, turn on Chesapeake Bay. Where did it go? Chesapeake Bay. Okay, placement. I already did this. Okay, and we will click polygon. Okay, click property, and I will set property appearance. Okay, so where is appearance? Okay, so now I'm gonna go appearance, and then states, appearance. Where is the bay thing? Okay, maybe it was just the bay watershed. No color, outline red. No color, outline red. Okay, I think this is the bay watershed. Okay. Okay, now I'm gonna label. Okay. Alright. And then property. Click property. Display. Property and appearance, no color. Okay, let's go to appearance. Symbology. Okay, so this one is no color and red. No color, red. Outline is 2. Click OK. There. And we will turn on reverse. I think turn on the Chesapeake Bay. Bay watershed. Okay, Bay watershed. Okay, then we will have a reverse. So reverse, let me find reverse. Okay, right here is reverse. So for reverse, I will double click the square, which is this, and click properties. So properties is right here in the symbology pane, and click the color square and change the color to blue with an outline. So outline color of gray. This is blue. Okay, and outline is gray, and the width will be 1. Okay. There, click apply. So now I have the river here. So, and then close the symbology pane. I'm gonna save everything. So now we can write something spatial observation. I don't think right now we can write anything. It's just really weird. Okay. Okay, so now I'm gonna zoom in a little bit. So that's the satellite image. So then turn on the zooming here. So I already have it on, and I'm already zooming. So that's this one, and I'm gonna right click on here and go to symbology. For symbology, we will see that the default band combination is RGB. So red, blue, red, green, blue. So band 1, 2, 3. Red is 3. Okay, that's it. Alright, which presents natural color, true color. So if we press the tab on red, we will notice that there are only 6 bands present. So yeah, and then green, yeah, the 6 bands, yeah. Alright. Then the result we will see shows that the thermal band is not presented. Therefore, band 6 menu, actually band 7, shortwave infrared. So earlier we mentioned that we can use different band combinations to enhance or represent specific properties. We will now set these band combinations. So I don't know if I'm gonna do copy it, and I think I'm gonna do so that I can turn on and off. The first one I'm gonna do 3, 2, 1, and right click on again, paste. And the second one I'm gonna do is 4, 3, 2, and then paste again. We will have a 7, 4, 2, and paste it again. And we will have a 4, 5, 3. Okay, so now I'm gonna right click on here, so go to symbology. So for symbology, I will have a 3, 2, 1. 3, 2, 1. Yep, I don't have to change anything. Let's double check again. 3, 2, 1. Okay, symbology. 3, 2, 1. Okay. And then right click on it, symbology. This one will be 4, 4, 3, 2. Okay, 4, 3, 2. Okay, and then this one will be 7. Okay. I don't have a 7. Band 6, 6, 6, 4, 2. Alright, and then 5, 4, 5, 3. Okay, only this one changes, okay. There. Okay. So now we can see the difference. Okay, so this is 3, 2, 1. 3, 2, 1, and then I'm going to reorder it. 3, 2, 1. Okay. Okay, so for 3, 2, 1, so this band combination, we can see it now. This band combination creates, let me zoom in a little bit more so we can see a lot better. So this is really nice, that we can see the true color or natural looking image. And this band combination is useful for barometric and coastal studies. And then if I check the second one, so the using band 4 in the red channel, so it results in more sharply defined water boundaries than in the 3, 2, 1 image. So by displaying the band that senses peak chlorophyll reference band 4 as red, vegetation appears. This is weird. Okay, let's see. Oh, why it's not showing? It's because I have this on. Okay. So here, using band 4 in the red channel results more sharply defined water boundaries than in the image 3, 2, 1 image. So by displaying the band that senses peak chlorophyll reference band 4 as red. So vegetation appears red. Generally, deep red hues indicate broad and or healthier vegetation, while lighter reds signify grasses or sparsely vegetated areas. So densely populated urban areas appear as light blue. So I'm gonna uncheck this. It will be 742. So 742, it will be, this combination retains the benefits of using the infrared band, yet represents vegetation in familiar green tones, and shortwave infrared band 7 helps discriminate moisture content in both vegetation and soils. Urban areas appear in varying shades of magenta, and grassland appear as light as green. And then the last one is 453. So with this band combination, vegetation type and condition are displayed as various in hue, browns, greens, and oranges. So this band combination highlights moisture, and it highlights moisture differences, and is useful for analysis of soil and vegetation conditions. So now we can write a description of the image describing different types of land cover and variation in bodies of water. Feel free to zoom in or more accurately. So I think we're good. Okay, and we will close everything, and we will zoom to the label DC, turn off water. So I'm gonna turn off water. Which band they didn't know. Go to map, bookmark. Oh, they didn't create a bookmark for us. Oh, right. We start from scratch, so I shouldn't have anything. But the issue was we will look at Jefferson Memorial, Lincoln Memorial, Refracting Pool, White House, and Capitol, and we will change the base map into imagery and turn off the states and turn off the states. Where is states? Okay, I'm gonna go to states. Turn off the states, and I'm gonna go to imagery, and then Checkers Bay. Okay, study area. I don't need them now, but I do. Let's see. Where is DC? Let's locate Washington, DC. Oh no, it's slow. Gonna go to Jefferson Memorial. Okay, so here is Jefferson Memorial. Now in the contents pane, and I will click this to make it active. So okay, gonna do this active. So then I'm gonna go to appearance. So for appearance, we will in the effects group. Okay, swipe. All right, I'm gonna swipe it. Where did it go? Oh, I need to turn this layer off, so. Okay, I'm zooming a little bit more. I'm gonna deselect this. There. Oh my god. Okay. Okay, I'm gonna hold it here. So we will compare the high resolution of the imagery in the Landsat image. So that's really cool. That this is oh, this is not clear. Okay. So we will compare the individual objects that can be seen in using high-resolution imagery and the lower-resolution Landsat, and then include possible usage of the imagery with different resolution. High-resolution imagery. This is high-resolution, and we can see like a lot clear boundary and stuff, and we will write assessment of the information offered by the different band combination. And now what we're gonna do is that I can see this is A, and then I'm gonna go to, I don't have to go another place, so I could just go to Google to look at other places like Lincoln stuff, but okay, White House. And alright, so we will investigate of composite bands. So I already have it here. So now let's go to our 321. So we will talk about the here again. So we're referring to this earlier chart, and this list includes the most common band combination. Okay. Okay, and then here, so 3, 2, 1. So this band combination that here, it creates a true color or natural looking image. So this band combination is useful for the barometric and coastal studies. We mentioned it many times. So 3, 2, 1, then barometric and coastal studies. And for 3, 2, so this is all. Okay. Let me put this on. Okay, so this one is the false color. We're using band 4 in the red channel that results more sharply defined water boundary. So here is sharp boundary right here. Then in the image for combination 3, 2, 1. So let's turn this on and off, and we can compare. Yeah, it's sharper contrast because red and black, and the other is just green and blue. The color is a lot closer. And by defining the band that sends peak and reflectance band 4 as red, and vegetation appears red. Generally, deep red hues indicated broadleaf or healthier vegetation, while lighter red signify grasslands or sparsely vegetated areas. Densely populated urban areas appear as light blue. So light blue, so this is urban area. So the more red, the healthier vegetation. The grayer means grassland or sparsely vegetated areas. So now I'm gonna turn 742 back on. So now this combination retains the benefits of using the infrared bands, yet represents vegetation in familiar green tones, and shortwave infrared band 7 helps discriminate moisture content in both vegetation and soils, and urban areas appear in varying shades or magenta, and green grassland appear as light green. And 453, with this band combination, vegetation type and condition are displayed as variations in hue, browns, green, and oranges. And this band combination highlights moisture differences and is useful for analysis of soil and vegetation conditions. And generally, the weather the soil, the darker it appears. So that we can see dark part. Oh, not this one. Yeah. So this one. So the darker. Oh, I can still use the swipe tool, but I have a more layer turned on. I'm gonna turn this off so I can swipe it. I have the word imagery. Yeah. Oh, I have to select this, then I can swipe it. But I have to zoom in a little bit. Then you can see. Yeah. Yeah, this has more feature, and this is just blurry. Okay. And now, so 5.3, this band combination vegetation type are displayed in various hue, brown, green, and orange. So the moisture. So the wetter the soil, the darker it appears. It's just really weird. So maybe this part a little darker. Maybe here we have a more moisture, and yeah, and then a little lighter, it's more urban area, so that's really nice too. So when we click the band combination, we can see two predefined combinations. The first is natural colors, 3, 2, 1, which is the rendition closest to what is seen by the human eye, and the second is color infrared, which is distinguished vegetation, urban, and water. And this combination shows more contrast in vegetation than land use. Okay. So we're going to select and right click, and we will okay, I'm gonna do this so that it will be interesting to see. Okay. So we're going to select, I'm going to uncheck this one. So what I did was I copy everything and I changed the band so I can turn it on and off at the same time instead of change one and go back and change it the other. So now I'm going to turn this back on. So now I'll go to appearance, and then there is a rendering, and we can do the band combination. So that's the band combination. So the first one we can do just natural color, and we will need to define the name to additional band combination. So here I can just do custom. So I can select band 6, and then 4, and then 2, and name. So here the name 7742. Click add. There. So and band 6 is display actually lands at band 7 because the thermal band is not displayed in the TIFF format. So we will repeat the step 4. So here I'm gonna do custom again, and then we will do 453. So here I have a 4, and then I have a 5, and then I have a 3. Click add. Okay, so there it is. So now we are ready to do a qualitative visual interpretation of the images, and we compare and contrast land features using different color composite images, different areas of interest. We will have defined before writing the final report. We can answer the following questions. So here we will do is turn on the area of interest. Okay, so that's where the area of interest, and then on the appearance tab we will do the transparency as 50%. Okay, so this is 50%, and we will click label the area of interest. So label. Okay, so now I'm gonna go to labeling, and then name, object ID, label. Okay, so label, I'm gonna change it into maybe red color, and I'm gonna do 16. There. It's 16 is still too tiny. 21, forever 21. Yeah, that we have different labels. So the label is different from the book, but it's okay. I think they updated the stuff. And where are the largest concentration of urban population? And we can see maybe just where is our okay, so I'm gonna appearance, band combination, natural color. What happened? Gonna select this again. I do 50% here. I don't want 50% here. There. Okay, so now we can see urban area, the most is number 3. And we can see the forest and agriculture. Forest we have C here, and agriculture in 2. So, and we will discuss where the population most likely to expand, and how it changes by investigating this land assessing. We can suggest areas that are vulnerable to natural disasters. Yeah, and then after investigating the land assessing, we can suggest areas that could be targeted for restoration. And once the analysis is complete, we still must develop a solution for the original problem and present the results in a compelling way. So the representation of the various data displays must explain that they show and how they helped solve the problem identified by the Chakotay Bay Foundation. So that's it. Next time we're going to look at Las Vegas. Oh, guys, you will love it. Okay, Las Vegas will be fun. So it's not a lot of work to do. So hopefully I will have time today to finish it.